Okay, we'll go ahead and get started here. And let's see here. All right. So it's maybe about at this time. If you're tuning in a little later, you might want to hit pause after we read this because maybe it's hard to read. So in a procedure of a hydrate, the mass of the hydrate is 11.75 grams, and this hydrate is cobalt 2 chloride. So after heating in this procedure, now we got a mass of 9.25 grams of the anhydride, and hydride remains. So then what is the formula of the hydrate? Okay? Where do you think we would begin in this case? Because we've got the hydrate, which means we've got the cobalt chloride. So what's the formula for that to begin with? COCl2, okay? Because this is -1, this is +2 because of this Roman numeral. The least common multiple is 2. That's why we end up with this. So our cobalt 2 chloride plus, we could say our water equals 11.75 grams of substance. Okay? So why is it significant that it says we have this many grams of the anhydride? What does that mean, do you think, when we say anhydride? Yeah, the water has been driven off. So that must be significant for a reason to give you two numbers here. If this is these two together, well, then this number must be significant then as well. So then you said this, does this have water in it? Because you made reference to water. So that must mean that what would we do with those two numbers then? We would subtract them, which means, yes, we've got 11.75 grams of our cobalt chloride, which means times X H2O. Okay, so that's our question mark right there, because that has, again, our cobalt 2 chloride and our water, and this is what we're trying to determine right here. So you said we would subtract, so then we've got 9.25, okay, so then that gives you your 0, 5, and then 2. So these two numbers are significant for what reason? I mean, my question is, you must be going to do something with these two numbers, or else we wouldn't be discussing those. Is it at this point you would like me to hit pause and work on this on your own, or together?
No, together. I don't think we really don't do that. So when you
Okay.
have the 2.5 as your hydrate, so then you do
2.5 is just water.
yeah.
Correct.
Subtract that.
Correct. So it matters how you explain this, because this being the anhydride means this is all you're dealing with.
Yeah, and then
So then, and then when you look at your other number, this one is this substance,
so then you would do the top masses of them.
2.50, and then 9.25. Okay? So we see these.
That's the supplement that's the whole element, like all.
Yes, this means you've got the cobalt 2 chloride and the water in there, but we just don't know what this number is.
That's why you find the
Mm-hmm.
moles, right?
Correct. But which one's which? That's the question we're asking. Well, that's why you have these two up here. So we would take 9.25 grams of of which one? Well, we put a box around here, so that must be significant. Okay, so we would change this to, for every mole of cobalt chloride, we must have in our molar mass grams of cobalt chloride. So, we're running out of space here. Equals moles of cobalt chloride. 129 point. Okay, so again, that's two cobalts, or excuse me, 2 chlorides plus 1 cobalt gives you that number there. Okay, so let's just stop with that one and move on to your water, which is saying we've got 2.50 grams of water that was driven off. And that would be 18.02 grams of water. Gives you a mole of water. And then this would be moles again of water. So we'll give you a little bit of time to get caught up with that. So how many moles of cobalt chloride do we have? I heard 0.0 0.07. Okay, and again, that is moles of cobalt chloride. What about moles of water? 0.138. Okay, so we do have 3 non-zero digits in each case. So then, what type of problem does this remind you of then? Yeah, this would be an empirical formula problem. Even though we're talking about hydrates, you would solve this in a similar manner. So then our next step must be what? Okay. So then our larger one, 0.138 goes on top, 0.0712, which if we were to analyze this and find out that if this number was bigger than that one, I think it would be fair to say we would have problems. Okay? And it could be a 1-to-1 ratio, but typically that's not going to happen because remember, we're solving for this. So since this is in a smaller amount, that means if we divide this into itself, we're just going to get 1. When we divide this by the smaller number, that will give us our question mark on how many moles of water there is. And when we divide that out, it comes out to just straight to, and it could be 1.98, it could be 2.02. Okay, so then that means for every mole of cobalt chloride in this compound, there is 2 moles of water. Okay, and that's how we do these empirical formula problems. So then let's switch this up a little bit where we're not going to be dealing with.
So how would you write it?
Oh. You would write COCl2 times 2 H2O. Okay, so now we're going to switch this up a little bit where, okay, We're going to disregard this number now because that's got water involved with it. What I want you to do is pick cobalt or chlorine. I mean, chlorine's probably a better answer.
Chlorine.
Okay? Wow, you're really thinking with that. Good answer. Okay? The reason I say that, we're going to be concentrating on this number. So we want to know of the 9.25 grams of this cobalt chloride, what is the percent composition of just the chlorine? So again, we disregard that number and that number. So 9.25, that's the one we want. If we have 9.25 grams of cobalt 2 chloride, what's the percent composition of that? So there are parts of this we really don't have to reinvent the wheel here, which means starting over from, we're starting over on our problem. This number's still the same.
We're finding the percent of chlorine.
Correct. Okay? So then, if this is step 1, how many steps are left, do you think?
3.
That is correct. Okay? Which means we can get rid of this here. Okay? So there is step 1. In step 2, do you want to continue with this on your own or together? Okay? So then for our molar mass, for every mole of cobalt chloride, how many grams do we have? That's why we said we really don't have to start totally over. We've got 129.83 because that number would still be the same as well. Grams of cobalt chloride. Okay. And of course these factors have canceled. Now we're in moles of cobalt chloride. Now we're moving on to step 3, which is so important. Why? Probably for maybe the 8th, 9th, 10th time we've said this. In step 3, it allows you to change what? Yeah, the amount of what we have, which is cobalt chloride, into the amount of what it is we're looking for, which is just chlorine. So in this step, we want to get rid of moles of cobalt chloride. So that means we put that on the bottom. Okay, and I have seen this on some of the papers, and this is not wrong. I don't recommend doing this, but some people maybe feel more comfortable with this. And they might just leave that and then put this here. That's not wrong. It's just not how I would recommend doing that, because when we start reaction stoichiometry, then you do have to put that number there. Okay, so you are compensating for that, but when we do this, I recommend the 2 comes from this one right here. So these are now gone. We're in moles of chlorine. So for every mole of chlorine, you get 35.45 grams of chlorine. Okay? But if you have been doing it like that earlier, maybe by this stage of the game you want to keep doing it that way. But again, it's just what I would not recommend. And that'll make more sense when we get to reaction stoichiometry. So we got numbers that are next to each other. We multiply. And then on the bottom, we divide. Okay, 9.25 times 2 times 655.83, which again, we're not done yet. We've got 129 to contend with. Okay, so then when we divide that out, and we get 5.05 grams of chlorine. Okay, but that's, if we were saying a molar mass problem, how many grams of chlorine are in this compound? Yes, that is true. That would answer that question, but it doesn't do that for percent composition, which means if this is how much chlorine we have, 5.05, we're going to divide that by, what would your guess be? This number or this one? The top one, which is 9.25. And then that will give us our percent composition. Which is 55%. Okay, so 55% of this compound, 9.25, is going to be that of chlorine. Well, if this is a 100% sample, we can look at this and say, we're not changing a whole lot here. We're going to take this out, and we're going to take this out. We're going to take this out. Because what happens if we do a mole of cobalt, our grams of cobalt is 58.93. So once we do the same thing, that number on the bottom does not change. That's still the same. So 9.25 times 58.93. That gives us 545. $545.10, and when you divide those two numbers, 545.10 divided by 129.83 gives you 4.19, we'll say 4.20, 4.20 grams of cobalt. Therefore, if we take that 4.20 divided by 9.25, as you would guess, comes out to 45%. Okay? So the math, as you can see, does work out. Whether you're doing chlorine, whether you're doing cobalt, 55% is chlorine, 45% then is cobalt. That's right. Because there could be a question might be asking what the percent composition maybe is for something a little more complex. And it could be, it doesn't have to be very big. It could maybe even be ethanol. Okay? To where you want the percentage breakdowns of that. Okay? All right, so we've got a lot of time set aside for this. So with what we've gone over here on the board, which is probably, you could say, quite a bit, which is probably pretty accurate. Front row, are we on the bus here? Okay, back row. All right. That is all I've got for today, unless there's something more that you want to go over. So notice that this does encompass everything that we've done this chapter, where you had to look at this, write out the formula. Okay? We took that, you had to add together its atomic mass, which is right here. We did an empirical formula problem. That's what we did up here before we erased part of it. And that was the last part, was this hydrate type of problem. Then we also did an empirical formula, and then a percent composition, and that's really, well, which again is quite a bit. This is quite a bit of content that we went over here. All right, so we will catch up to you next time.